Okay, so we are going to talk about multiplication. So far, we have already talked about the zero and negative rules, but today's lesson is focused on product, which means to multiply. And on the next page, we're going to talk about the power rule. So we're going to simplify expressions using the product properties and the power rule. So product property just means that we're multiplying things. So here, we want to figure out what is the product of 2 to the 5th power and 2 to the 6th power. Because these have the same base, there's going to be a shortcut that's actually written at the bottom of the page. So if you want, go ahead and hit pause and read that now. Otherwise, I'll come back to it. But the main idea is that we need to understand how these things expand in order to be able to figure out what the answer is or to be able to utilize the shortcut. So for example, 2 to the 5th power, we really know is 2 times 2 times 2 times 2 because exponents are repeated multiplication, times 2 to the 6th power, 2 times 2 times 2 times 2 times 2 times 2. Now, I can rewrite this as, well, how many do I have altogether? Here I have 5, here I have 6, so altogether I have a total of 11 2's getting multiplied together. Now you can take your calculator and do 2 times 2 times 2 times 2 and figure out what the actual number is, but I don't actually care because sometimes when you deal with exponents, the numbers get so big that your calculator can't even handle it. 2 to the 11th power, 2048, that your calculator can handle that one, but you'll see some other ones not so much. You'll get an error or it'll give it to you in scientific notation. The shortcut here is to recognize that if you have the same bases, the bases are 2 in this case, and then our exponent is 5 and the other one is 6. The shortcut is if they have the same base, then you can add the exponents. And that's what it's saying down below. Here's an example where the base is 6 both times, so the shortcut is add the exponents, and that's going to happen anytime with multiplication. But if the shortcut doesn't make sense, don't use it, because expanding is going to work every single time and it only takes an extra couple of seconds to complete it. So you're going to be able to expand to find the answer or use the shortcut to find the answer moving forward. You can pick. However, you need to expand in order to be able to understand the shortcut. So here, for example, a to the 4th means I have a getting multiplied together, times b to the 5th times a to the 2nd. So a times a. So all of these things are getting multiplied together. What I can do, though, is reorganize it to simplify. My goal is to simplify. The a's can all group together. How many a's do I have? A total of 6. How many b's do I have? A total of 5. So this is my final answer, but the shortcut could have been written as a to the 4th plus 2 times b to the 5th. Now, right now, it might seem easy to just add the exponents, but when we start to learn the other rules, like product to proper, like the product rule, or I'm sorry, power to power rule, and when we learn the quotient rule, we start to confuse some of the shortcuts. So that's why I strongly recommend expanding, especially when you take an assessment. So go ahead and hit pause and see if you can figure out what C and D are. We have y to the 2nd, y times y times y times y to the 4th. So how many y's do we have total getting multiplied together? We have a total of 7 y's. And the shortcut would have been y to the 2nd plus 1 plus 4. Because remember, if there is no exponent, we can assume that that's a 1. Because y to the 1st and y are the same thing. Now, this next one, m to the 3rd, m to the negative 1. We know that that means it needs to go down to the bottom. and then m to the second. Okay, so now that it moved down to the bottom, it's a positive exponent. We haven't learned this rule yet, but those will be able to cancel, and we're going to be left with technically m to the fourth power. But the shortcut would be adding these exponents together. 3 plus a negative 1 is 2, plus 2 is 4. So it even works when you deal with the negative exponents. And that example will make more sense after we learn the quotient property. So again, make sure you take a second to read this and understand it if you haven't already. Flip to the next page. This page is focusing on the power to power rule, which means we have an exponent, which we call a power, and it's being raised to another power. So the first power is 4, and the next power is 3. So we have power to power. And what this means is that this 3, the base of the 3 is the entire thing. So what I really have here is 7 to the 4th 3 times. But 7 to the 4th really means 7 times 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 7. Now, that's going to give you a very, very large number in your calculator, but I don't care what the actual number is. I care that you understand how we can simplify this. How many 7s do I have all together? There's technically 12. But the shortcut is when we use the power to power, we can just multiply the exponents. Oops, I wrote that wrong. Let me rewrite that. It would be 7 to the 4 times 3. 4 times 3 makes 12. So the way I keep these shortcuts separated, I think of power to power, that's like a really aggressive multiplication. Things grow really, really fastly. And when we multiply things together, they grow a lot faster than if we are adding things together. So when we're just multiplying, we're expanding, and yeah, the number grows, but it's growing slowly, and so we use addition for our shortcut. When we do power to power, the number grows way faster, and so we need a more aggressive way to grow a number, which would be multiplication. That's how I think of it. You can remember it however you want. So go ahead and hit pause and try to complete F, G, and H on your own. So for F, this 2 is on the entire thing. So I have 2 to the 3rd power times 2 to the 3rd power. I had 2 of them. But 2 times 2 times 2 is what's really inside each of these. So what I really have is 2 to the 6th power, but the shortcut would be 2 to the 3 times 2 power. If you haven't, take a second to read this rule that gives you an example and an example using variables, which means it works for everything. This one's tricky. Did you figure it out? This whole thing is to the 0 power. Anything raised to the 0 power is 1. So I don't need to expand this. The answer is 1. Tricked ya, or did I? Maybe you got that, and if you did, awesome. Next, this one also is a little bit tricky because we have a kind of a compound situation happening here. Can you figure it out? Hit pause. This 4 is on the entire thing. So I have x to the 2nd power 4 times. Then I have x to the 3rd power. So if I expand this, in the first parenthesis I really have x times x, and then I have that again in each parenthesis, and then x to the 3rd looks like that. So how many x's do I have? X to the 11th, and I said this was kind of a compound situation. It's because we have power to power rule, then we have multiplication. So the shortcut would be 2 times 4. Oops. Where's my whiteout? There we go. 2 times 4 plus 3. 2 times 4 is 8, plus 3 makes 11. So again, try reading this rule to see if it makes any more sense than it did a few minutes ago. And now, hit pause and see if you can do these ones on your own. This 3 is on the entire thing. And this is just a bunch of stuff getting multiplied together. This is 4 times p, times 4 times p, times... So I could rewrite this 4 times 4... Oh, sorry. 4 times p... Lord, shouldn't be using pen. 4 times p times 4 times p times 4 times p. I could look at it like that. And then if I wanted to reorganize it, it's really 4 times 4 times 4 times p times p times p. So I could either write this as 4 to the third power p to the third power, or 64 p to the third power. Usually we will write it like this, especially when the numbers are smaller, like 4 to the third power, it only makes 64, so that's a pretty small number. So we'd write it like that. So the shortcut here is that the exponent on each of these is technically a 1. So the 3 distributes to the 1 and to the other one. So it becomes 4 to the 1 times 3 and p to the 1 times 3. 1 times 3 is 3. 1 times 3 is 3. So you'll see that a little bit better here. Yes, this 3 is on the entire thing. Which means I really have 4 times p times p times 4 times p times p times 4 times p times p. So I still have I still have 3 of the 4's getting multiplied together. But how many p's are there now? 6. So what I mean with the distribution is this 3 is going to distribute to the 4 and to the p. And if there's no exponent, we can assume it's a 1. So it becomes 4 to the 1 times 3 and p to the 2 times 3. 1 times 3 makes 3. 2 times 3 makes 6. If that didn't make sense or you need time to process it, hit pause, rewind it, listen to it again, maybe listen to it a third time till it sinks in, because the more you hear them, the more they make sense. Can you figure out k on your own? Hit pause and try it. This 2 is only on the parentheses, so only the parentheses are going to get repeated twice. And so this becomes negative 3 to the second power, x to the second power. But you have to be extra careful, because when you put that into your calculator, if you do it wrong, it's going to give you the wrong answer. The final answer that we would prefer would be this. But if you get a positive, you're doing something wrong on your calculator. There's a bell. The shortcut, again, these are both to the first power, so that 2 distributes to each one, and we could rewrite this as 3 to the 1 times 2 times x to the 1 times 2. 1 times 2 gives us 2, 1 times 2 gives us 2. So again, if you feel lost right now, then you should probably rewind this whole thing and watch it again. if you feel like it's kind of making sense, take a look at the next page and start your homework. Your homework's on the next 2 pages. Make sure you expand and do the shortcut. Do both, because then you can get a better idea as to what one you prefer. When you move forward here, you can use whatever method you like, shortcut or expansion or both, to check your answers. So you're doing the next page and the page after that as well. That last little section is considered optional. It is a little bit more challenging, but it is optional. And I know we haven't talked a lot about scientific notation, so just try your best with that, and we will go over questions in class.